A preference for the less general, the more specific generalization, be a sensible preference to have, right? For like, why it seems like babies have it, great, but why? And the answer is that it's a way to make ambiguous data actually informative. So ambiguous data would be the stuff here that's compatible in this case with both the subset hypothesis H1 and the superset hypothesis H2. And this solves something that's been called the subset problem. And so let's walk through what that is. And the idea is simply this. What if children preferred H2, the superset hypothesis, but the right generalization was actually H1, the more specific subset hypothesis? Ambiguous data are a problem because all data compatible with the subset are, of course, by definition, compatible with the superset too. So how would the child ever realize that her generalization was too broad, that she needed to shrink down to the subset, because there are no unambiguous data to indicate this? Why not? Well, let's consider a specific data point, x1, right here. So this is the data that she will actually see. It's the only data point that will appear if that subset hypothesis is actually the correct generalization, right? x2 won't show up because that's compatible with the broader one, which is actually incorrect. You're only ever going to see x1. And the problem, of course, is that x1 is compatible with both h1 and h2, right? Like, this is not disconfirming evidence for h2. It's not unambiguous for h1. It's compatible with both of them, right? And so this is the subset problem in a nutshell. And note that no other situation is actually a problem, right? So if H2 is actually true, if that's what the language does, you'll see both of these. And so if you, for example, mistakenly thought H1 is right, then seeing X2 is an unambiguous signal to revise your hypothesis, right? You have to expand up to include that superset data point, right? And you're like, oh, so if I thought it was H1, but now I see X2 over here, oh, I need to expand up to include that counterexample to H1 to be therefore make my generalization H2. So what to do when you think H1 is right, but the child, when H1 is actually right, but the child thinks H2 is the right one. So what happens when you think the superset is the right one, but the subset is in fact true? Well, that's why it's useful to have a bias to prefer the subset hypothesis. And this can be implemented with what we've been talking about in a couple of other of these podcasts, the general purpose, that is the domain general used across cognitive domains, probabilistic reasoning mechanism